Today I talk about something that I research now, but it's not my principal area of research. So, I started doing this for fun, and by the end it became a serious stuff. So, but this is a joint work with Adriano Suzuki, Luis Ernesto Salazar, it's here, so I present. If you have some doubts, you can ask him. And this is José Galvão Leite and Anderson Ara. And we are from the São Carlos University and the USP in the São Carlos campus. So the main idea here is to propose a simulation based on the method for predicting football outcomes, and we adopting a Bayesian approach for doing that by modeling the number of goals of two opposite teams as Poisson distributions, and whose means here are proportional to the relative technical level of the opponents. We are considering for this stuff here, the technical relative level, the FIFA ranks. And we try our methodology to the last World Football World Cup. And also we are giving some flavor for the next one, but it's just flavor. It is the outline of the talk. I go briefly to an introduction about the tournament. I point out the model formulation, prediction, results, and some final considerations. Well, first, we need to say that the World Cup tournament is organized by FIFA, which is an international association, and takes place every 4 years. We have in the competition 32 teams from different continents, and the teams are organized within 8 groups and with 4 teams each. And you have 2 stages. The first stage, when each group plays a round-robin tournament, and the 2 top teams comes to the next stage. And in the second one, which we call knockout stage, it's a single elimination tournament, which the teams plays each other in an off match. And if you need it, if you have some draw, you go to the next time at 30 minutes. Well, here is the groups of the last World Cup edition. So here we have Brazil, Korea, Portugal. No? Here we have Spain, which by the end becomes the champion. We have here Argentina, which are our hermanos, because well, what you need to know is that there is a lot of interest, academic interest, in statistical modeling to sport data. Particularly nowadays, several groups start to work on this kind of research. And you have several journals that you are allowed to publish this kind of research. And including us, we have a research, a paper published by this society here. And also, we have several authors having been considering football score prediction applied to championship leagues. But when you come to the World Cups, you just find few articles. Maybe this can be explained by the limited amount of valuable data related to the international matches. In particular, you have a great distance between the World Cup editions. And also have few competitions to keep which put together teams from different countries. So you have a lack of data. This is the point. So maybe because this you have this small amount of papers. But outside the university, you have a lot of guys that try to predict football matches as well. For the last World Cup, you have some guys that try to predict this. One said that Brazil will win the World Cup. He was wrong. The final will be Brazil and England, Brazil, France, Brazil, and the Italy or Germany. Germany will be the champion. Everybody was wrong, really. But what happened that the media talk a lot about that, these predictions. So we have also animals. We have the fowl, the octopus in German. We have Pauline, a female octopus. we have Money, the market in Singapore, and you have Judith, a donkey in Brazil. She tried, she's a female donkey, and she tried to predict as well, but she starts longer. But now it's our turn. So it's our turn. We start to consider so that our probabilistic model. It's a simple probabilistic model, but we can use this simple probabilistic model in our simulation scheme. This is the point. So we're considering here a match between the teams A and B with respective FIFA ranks, RA and RB, and you assume that these two random variables, the number of goals scored by the teams A against B and the B against A here. And you assume that they are two independent Poisson distribution random variables here. And in this particular situation, the means are proportional to the relative technical level of the opponents. So what happens that if you have a FIFA rank, if A is better than B, A, you have the mean of its distribution increased, otherwise it will be decreased. This is the modeling that we have considered. Also consider subjective information in the sense that the number of S experts provide they expect the final scores for the incoming match which we intend to predict. We have considered this structure, and then assuming independent expert opinions, we obtain the prior distribution for the parameters of interest, which are lambda A and lambda B, by using a procedure analogous to the power prior method which was proposed by Shen in 2002. But now we, instead to consider the historical data, we replace the data by the experts expected scores. So I mean, first, before considering the information about the experts' opinions, we assume a gamma distribution as prior information for our parameters. In the sense that in some elapsed cases, you have a Jeffrey prior for the Poisson model, or even a uniform distribution as well. So I'm combining this information, this prior information, with the expected scores, we obtain so the power prior for lambda A, say for lambda B is the same. By then you have this gamma prior for the lambda A giving this initial data which denotes the experts expected scores. And one thing to think here is that the parameter A0 can be interpreted as a degree of confidence in the expert's information. If you agree with the information, or if you trust the information, you give a high value to A. Otherwise, you give a small value to A. After that, so you come to our interest, which is the predictive distributions for XAB and XBA, which are the number of goals of each team. So, I mean, we have here the situation, we have two sources of information. First, we have the experts expected scores, and they also have the actual scores of the matches already played. So in this sense, you have two distinct situations. One, when you have only the experts' information. This is usually before the beginning of the competition. This is what we have done for the last World Cup in first time. And now you will give just a flavor about that now. Just run yesterday night, this simulation. And also you have the expected information and the scores the players already played. Really. So you have these two sources of information. So in this situation, the predictive distribution for XAB is a negative binomial with these two parameters here. And in the situation E2, we also have a negative binomial distribution as the predictive distribution, but we are considering here a 8 likelihood when these eights are given by this vector fixed eights assigned to each match, in order that I can control how much importance I should do for each game. So the best games should influence it less than the nearby games. So we can choose different eights here. By then, this is the posterior predictive distribution of EBEB in the other case. And one thing that is very important for us, at least in principle, is that we have a closed form for this predictive distribution, because we are using this. We needed to use since we have a site that we put everything together at site, you run simulation online, we need a model that could give you answers in real time. So I mean, it's important for us to have a closed form here. Well, to get that subjective information, we're considering, for the last World Cup, we're considering 4 experts that provide the expected guess. For all matches in the group stage, which is the first stage, and in the second stage, they provide the expected final scores only for the matches in the income round. So by the end with this modeling, you could provide the probabilities of win for each team in each one of the matches, given by these expressions here. And then, given this modeling, we now are able to make the tournament simulation. So we have considered the simulation of 10,000 tournaments. First, to read our data, which we have, and after that, to generate the scores of the first stage from the predictive density, sort teams within the groups, and after that, to generate the scores for the second stage, store the simulated team trajectories, because they are very important for us, and after that we calculate the percentages of interest. So I mean, using this procedure, we can calculate, for example, the probability that a given team will win the tournament, that this given team will reach the final, that which is the probability that this given team classified to the knockout stage, and so on. This kind of usual kind of probabilities that are interested. So some results that we have obtained for the 2010 World Cup. This is the predictions of the round of 6, considering here some of the teams here, and you consider the definite distance for goodness of prediction. Well, the definite distance is really the square of the Euclidean distance between the point corresponding to outcome and to the one corresponding to prediction inside this simplex set. Because it's if you have all the possible results from a game are inside this simplex. So what happens that if you have a definite measurement smaller than 2/3, we can observe that this prediction is better than just considering a improbable predictor. So it's the prediction of the match of the group G, which is the Brazil group here. You note that several definite measures are smaller than 2/3. This is the classification probabilities by group for all groups. Now I open these groups to see the Brazil here, and you have predicted that Portugal and Brazil would go to the next stage. I believe it's 12 days before the beginning of the World Cup. And this happened by the end. And also, this is the probability of the 6 best teams for the second stage. And we point out here that Spain and the Netherlands would be in the final probability. They have the highest scores here. And this is, you observe here, this is the output of the 10,000 tournament simulations, and you observe that these teams, we have predicted that these teams here would be in the final, and indeed you have at least 3 teams that were in the finals. Also, we will try to see if you have impact of the different weights in the win probabilities. And of course it is, if you consider different weights here, and you observe that you have different values for the win probabilities. This means that if it is important, you decide if you will consider that the results from games that are the best several times have the same importance that the results that just happened. In our case, we are preferred to consider that in this situation when we're giving all the same importance for all the team, all the matches. Here you have the impact of the experts' information on the quality of the predictions using the definite measurement. This is the solid line is the represents a fictitious pool of perfect experts in the sense that they guess will coincide with the observed results of the matches. So it should be the best prediction that we have done. This is our prediction considering our pool of experts, and this is the situation when you don't consider the information. And you observe that the expert information is important, particularly in the beginning of the competition, when indeed you don't have any information about the match between the teams. So we create a site when all the information were exposed there for each round of the World Cup. In addition to the forecast, the internet users could provide their opinion instead to consider the experts' opinions. We provide a place when they could consider the expert opinions about the matches and interact with the modeling. Really. So I mean, it was very interesting because we had a lot of feedback about that. Particularly, the model was one of the only ones to predict the final Spain and Netherlands in this order. We have more than 80 articles, newspapers, blogs, TV here in Brazil and abroad, include this model, and include the major newspapers of Brazil and the main TV stations. Over 53,000 visits in our website. More than 11,000 simulations have been done there. Well, and finally, we present some initial results for the 2004 World Cup, but I mean, we have considered that, just consider the not expert information, but our information. So I mean, you should be wrong. No. Luis Ernesto information. Well, if they consider my information, maybe the model would be very wrong. So I mean, maybe it's better this guy. So I mean, this is the Brazil group. We are predicting here that Brazil and Mexico will be in the next stage. This is the Spain group, which Spain was the last champion. They will pass through for the next stage, Netherlands and Spain. This is the group we call group of dads because we have 3 ex-champions, Italy, England, and Uruguay. We believe, I mean, the model is saying that the Italy and the England will be in the next stage. And finally, this is the Argentina group, and I mean, Argentina will be easily to the next stage. And this is our guess for the probability of win. So Germany first, Argentina, Portugal, Brazil, Italy. Okay? So So I mean, if you don't trust our model, it's okay, because you can wait for the octopus once. So, okay, thank you very much for your attention.